So, good afternoon, guys. Welcome to NEET World Institute and NEET World YouTube channel. So, in this topic, in this session, we are going to see the topic that is atoms. So, this atoms, no, like in this chapter, in class 12th IPE, they will ask short answer questions. From the short answer questions, the atom, a topic is there. So, like it consists of 4 marks. Okay. And before that, I'll tell you the point. See, our NEET World Institute has designed the IP material according to the AP and Telangana syllabus for class 12th and class 11th students. Okay. So, this is for both engineering and medical, that is MPC and BPC students. Okay. In this, like you will get maths 1A, 1B, 2A, 2B, and then physics for class 11th as well as 12th, chemistry also for class 11th as well as class 12th, and then if you see for botany and zoology also is there. Okay. So, this material you can get through our app. So, the simple thing you should do is you should follow the social media accounts of NEET World Institute, and then you need to download the MedWorld app, which is available in the Play Store. So, after downloading, now you should sign it up. So, in that you will have a chat box. So, in the chat box, just give a hi message. Okay, and our team will be in support with you, and whatever material you want, you will get in a soft copy. Okay. So, don't worry about the money, like it's free to everyone. So, since the IP exam is going to come now, so we have provided every material as of now as free. Okay. And whatever the material you are getting, the session, like whatever the questions are there, no, we have explained in a YouTube channel, so you can go through that also. Okay. Yeah, let's go into the topic. So, that is today's topic is atoms, so which is from class 12th. So, this is from class 12th right now. So, if you see, you will get short answer questions, that is which is 4 marks from this chapter. Okay. So, in this chapter, no, like most of the things will be a theoretical part, and some it will be like equation, we need to derive it. Okay. We will see everything here. Okay. The first question of this session, if you see, yeah, describe Rutherford atom model. What are the drawbacks of this model? So, 2 questions have been given in the first question, like 2 sub questions. Okay. I need to describe what is, yeah, Rutherford atom model, and I need to list out what are the drawbacks of that model, right. So, if I want to list out the drawbacks, I need to say some advantage of that also, right. So, let us see that. Okay. So, if you see the first one, yeah, atom is a spherical and mostly a hollow shape. Okay, that's the first thing, like a Rutherford nuclear model of atom. Okay, and the second point is the positive charge. Smiling wait, hi. Okay, so the second point is the positive charge and the mass of the atom is concentrated in a small region at the center. When you talk about the atom, no, if you see here, it's mostly a spherical shape, right, no, and whatever the thing, like atoms, no, like will be at the center of the, yeah, center of that sphere, and radius of the nucleus, no, if you see, it is 10 power minus 3 to 10 power 15 minus 15 meter, and the radius of the atom is 10 power minus 10 meter. If you see about the nucleus, it is minus 13 to minus 15. And whereas it is atom is nothing but it is 10 power minus 10. So, first 3 point it's clear, I guess. So, atom is a spherical and a hollow, mostly in the hollow shape, right, no. And if you talk about the second point, it's a positive charge, positively charged, and it will be located in the center. And when I talk about the third point, the nucleus, radius of the nucleus and radius of the atom, two things are there. So nucleus is 10 power minus 13 to 10 power minus 15 meter, whereas the radius of the atom is 10 power minus 10 meter. Okay. Next, the electron present outside the nucleus. If you see this one, no, the nucleus, like it present outside the nucleus, if you see carefully. Okay. So fourth point is it present outside the nucleus, like called extra nuclear part, we will say, are equal in the number of proton inside the nucleus. See, whenever we are talking about the things, no, like protons and electrons, no, will be equal. Whatever the proton are inside will be equal outside also, like the electron will be equal outside. So now, just as a planet revolve around the sun, the electron also revolve around the nucleus. If you see here, electron, it's revolving around the nucleus, right? It's a nucleus, center part is nucleus. In that nucleus, the center part is there, no, that is the atom, that is a proton, positively charged. So this electron is revolving around this. Okay. And sixth point, the last point which we want to say is the revolving electron are under the influence of two forces. So the centripetal force and centrifugal forces are there. So centripetal force will be towards the center. Okay. When I talk about centripetal force, no, it will be towards the center. Right? No, centripetal force towards the nucleus, that's center. Nucleus is the center, right? And when I talk about the centrifugal force, no, directed away from the orbital path. Directed away from the orbital path, and these two forces being equal and opposite direction and balance each other, and electron continuously revolve in the orbit. Two forces, one is centripetal, one is centrifugal. Centripetal will be towards the center and the centrifugal will be away from the center, right? And both are equal and opposite in direction. So because of this, the electron keeps on revolving. Okay, these are the 6 points, you need to note it down. Understood the 6 point? So after noted down now, like we can go for the the drawbacks we will go. Got it? Okay, can we go for the next one, that is drawback we need to see, no? So if you see the drawbacks, no, so the first drawback, if you see here, I'll read it out first and let me explain it. According to Rutherford's model, if any charged particle moving under the influence of oppositely charged particle, then the particle loses energy continuously and come closer and closer to the nucleus and finally falls into the nucleus. So then the atom shell collapses due to merging of electron with the nucleus, but it has not happened. Okay. So first point what they are saying is, when it like charged particle moving under the influence of oppositely charged particle, no, like because of this positively charged and this electron is moving. So what happens here is they lose the energy, right? When they are losing energy, it keeps on revolving and coming closer to closer. If you see here, it is coming closer to closer and falls in the nucleus, right? That's the first point they are saying, and then it get collapsed. Okay, the shell get collapsed. If electron loses energy continuously, second point, the atomic spectrum should have continuous bands. So instead of continuous bands, the lines are observed. Okay, this is the second point. And third point is, it does not explain the electronic structure of the atom. Okay, if you see here, it does not explain the electronic structure of the atom as how the electron are distributed around the nucleus and their energies. Okay, they have not explained the electronic structure. That is the third point, important thing. they have not explained the electronic structure. Okay, so this is third point, and if you see, yeah, we'll go for the next question. You can take it down and we can go for the next question. Completed? Can we go for the next one? Okay, done. So the next question, if you see, yeah, derive an expression for potential and kinetic energy of an electron, potential and kinetic energy of an electron in an orbit of an hydrogen atom according to the Bohr's atomic model, and how the potential energy changes with increasing n. Okay, that's the question here. So first of all, if you see here, as per the Bohr's atomic model, no, the electron are revolving around the nucleus in a certain permitted orbit, right? No, certain permitted orbit. For that, if you see here, like we know the, yeah, we know the electric field force, right? What is the electric field force? If you see electric field force, F is equals to 1 by 4 pi, or we can say F is equals to K Q1 Q2 by R square, or else 1 by 4 pi epsilon naught Q1 Q2 by R square, right now. And for the electron revolve in an orbit now, the electrostatic force and centrifugal force must be equal. It must be equal, because we are talking about the electron, right now. When we are talking about the electron, we are talking about the electrostatic force, and that electron keeps on revolving because of the centrifugal force, I mean centripetal force, right now, centripetal force and centrifugal force, right. And if you see here, Fc should be equals to Fe. What is the formula? F, say mv square by r should be equals to 1 by 4 pi epsilon naught E square by R square. Like instead of Q1 Q2 we have taken E square. Okay, so here R and R will get cancelled off, right. So mv square will be equals to E square by 4 pi epsilon naught R, and we'll go for the next down. Yeah, so now the kinetic energy of an electron, like we know the formula for mv square now. Mv square is nothing but E square by 4 pi epsilon naught R. So what is the formula for kinetic energy of mv square? So half into mv square is nothing but E square by 4 pi epsilon R, no. So we have multiplied this 2 here. So 1 by 8 pi epsilon naught into E square by R is the kinetic energy, right. When I talk about the potential energy formula is U is equals to minus 1 by 4 pi epsilon naught E square by R, right, E square by R. So this is potential energy formula, and that is kinetic energy formula. Now the relation between, yeah, and one more thing, why this negative sign has been given is because of the force of attraction. Okay, the force of attraction, because of that negative sign we have taken. Okay, fine. So the relation between potential energy and the radius of the orbit. So potential energy will be equals to minus 2 times of the kinetic energy, and when I talk about the relation, no, it is inversely proportional. If you see here, U is inversely proportional to the radius. That's the thing they are asking. What is the relation between the radius and the potential energy, right? Yeah, that is the thing. You can take a note of this and we can go for the next one. Yeah. Done? Okay. Now the next question is, yeah, I guess it's clear now. The page is clear. So what are the limitations of Bohr's theory of hydrogen atom? So there are 5 points here. So first point is, it could not explain the spectra of complex atom which is having more than one electron. If we have more than one electron, no, we cannot explain the thing. Like that's the one of the limitation of Bohr's theory of hydrogen atom. And second one, it does not give an idea about the distribution of electron in an atom. It does not give the idea and it cannot explain the complex like a spectra of the more than one electron. Third point, this model could not account for wave nature of electron. Okay, and fourth point, I will mark the points here so that it will be easy to understand here. So spectra of complex atom like more than one electron, and if you see here, like it does not give an idea about distribution of electron in an atom. And third point, it could not account for wave nature, and it does not give any idea about the relative intensity. So there is no idea of relative intensity. And fifth point, it does not explain Zeeman effect and Stark effect. So Zeeman effect is not there and Stark effect also is not there. They have not explained. So these are the limitations of Bohr's hydrogen atom. Okay. So once it's completed, we can go for the fourth question. Yeah, still few pages are there, we can see easily. I guess done, right? Yeah, we can go for the next one. So the fourth question. Yeah. So state the basic postulates of Bohr's theory of atomic spectra. So there are three things. Okay, the first one, if you see, an electron in an atom could revolve in a certain stable orbit without the emission of radiant energy. And second point, if you see, the electron revolve around the nucleus only those orbit which angular momentum is integral multiple of h by 2 pi. Okay, electron which revolves around the nucleus. Okay, that one only we are talking. So it's nothing but where like h is nothing but it's a Planck constant 6.6 into 10 power minus 34. Okay, there is the thing. So third point, if you see, the electromagnetic radiation are emitted if the electron jumps from a stationary orbit of higher energy level E2 to another stationary orbit of lower energy. Like electromagnetic radiation are emitted in an electron jumps from stationary orbit of higher energy level to stationary orbit of lower energy level, which is nothing but HV is equals to E2 minus E1, like higher level to lower level, I minus low. Okay, these are the 3 points about the Bohr's postulates. Yeah, once completed, we can go for the next question. Done? Okay. So the next question is, explain different types of spectral lines. Yeah, we'll see. This is the one of the important question, right? So in this you will have, yeah, I guess it's clear now. So page is visible. Yeah, Lyman series. The first one is Lyman series. In the spectral line, the Lyman series. So spectral line correspond to transition of electron from high energy state to lower energy state, that is N1 is equals to 1. Okay. So the formula, if you see, R into 1 by N1 square minus N2 square. Okay. Where N2 is 2, 3, 4, like the next levels. Okay. From the first level to the second level, third level, fourth level, we are following. No, if you see the diagram, no, I'll show you the diagram so that it will be easy to understand that. Yeah. So this is the diagram for this. So Lyman series, Balmer series, Paschen series, bracket series, and Fun series. Okay. So energy levels increases like this. Okay. So the first one, if you see Lyman series, no, so N1 will be 1 and N2 will be 2, 3, 4, etc. And when I talk about a Balmer series, no, N1 should be 2 and N2 should be 3, 4, 5 like this. Like spectral line correspond to transition of electron from higher energy state to lower energy state, that is N1 is equal to 2. Okay. And when I talk about the first one, no, Lyman series, it's a UV region spectra, and Balmer series is visible region okay, visible region. So Paschen series is N1 will be 3 and N2 will be 4, 5, 6 and goes on, etc. And bracket series, yeah, automatically you know that, like N1 will be 4, and when I talk about a Fun series, N1 will be 5 and remaining N2 will be 5, 6, 7, etc. and N2 will be 6, 7, 8 and goes on. So in this, like bracket series, no, it's a middle of infrared region. IR means infrared region of a spectra. Okay. This is about the fourth one, and fifth one, like as usual, like N1 is equals to 5 and N2 is equals to 6, 7, 8. So when I talk about the thing, no, like this lies farther from the infrared region. Okay, and this is the diagram of that. Yeah, you can take a note of this and we can go for the next question. Pratima Thakur, hello, hi. Yeah, so now we are going for the last question. Okay, so write a short note of de Broglie explanation of Bohr's second postulate of quantization. Okay, so like as I told you that, like in this lesson it's full of theory only, there is no derivation, nothing. Like I need to write theory part and I need to write the equation of that, that's it. So only memorizing thing in this lesson. Okay, I'll explain you the things, what are the important points here, and we can take the points from there. Okay, so if you see, according to the Bohr's second postulate, no, the angular momentum of an electron orbiting around a nucleus is quantized. Angular momentum, okay, angular momentum of an electron orbiting around the nucleus is quantized. And Louis de Broglie's explanation, what Louis has been explained here, argued that electron in a circuit orbit as proposed by Bohr must be seen in a particle wave. Okay, and in analogy to wave traveling on a string, particle waves to can lead a standing wave under resonant condition. Like the thing is, particle wave to can lead to standing wave in which condition? Resonant condition. Okay, and we know that when a string is plugged, a vast number of wavelengths are excited. When I start disturb the strings, no, what happens here? Like n number of waves are produced. So however, only those waves survive which have nodes at the end and form standing wave in the string. Okay, so which will be taken? So only have nodes at the end. Okay, so it means that in string, standing waves are formed when the total distance travelled by the wave down the string and back in one wavelength. And if you see here, two wavelengths are an integral number of wavelengths. So waves with wavelength interference with themselves upon the reflection, their amplitude quickly drop to 0, right? So if you see, I have marked the points, no, you can take that points as the important thing. Okay, yeah. So for an electron moving in the nth circular orbit, right, so the total distance of the circumference is nothing but 2 pi rn, right? No, like the circumference is 2 pi rn, and when I talk about the last one, the formula, which is nothing but 2 pi rn is nothing but n lambda, where n is nothing but 1, 2, 3 and goes on. So where lambda is de Broglie wavelength of an electron in nth orbit. So if the speed of an electron is much less than the light, its momentum is m into v, which is nothing but lambda is equal to h by mv. Okay, where Planck's constant is, we know, like h is Planck's constant and mv momentum, okay, and lambda is nothing but wavelength. So if we rewrite that equation, it is 2 pi rn will be equals to n times h by mv. Okay, this is the final equation we need to conclude in this question. Okay, yeah. So with this, I'll conclude the session of this atoms. Okay, so in this no, like the important thing is the fifth question is the most important thing. Like n number of times they have asked Lyman series, Balmer series, bracket series, fun series. Okay, so you can take that, and like everything is important. Okay, but please concentrate on the fifth question mainly. Okay, so with this I'll conclude the class, guys. You can revise it and we'll meet in the next class. Okay, bye bye.